Now we will study the new concept, electric dipole. What is an electric dipole? A pair of equal and opposite point charges separated by a small distance constitute an electric dipole. Now consider here two charges. Now here we have a negative charge minus q, okay, and here we have a positive charge plus q. Now these are a pair of equal and opposite charges. Now they are separated by a small distance. Let me take the distance as 2a. If 2a is the distance of separation between those two charges, now this system of pair of equal and opposite charges separated by a small distance constitute an electric dipole. Now the line joining the two charges is called axis. Now this is called the axis of the dipole. Now this one is. Now the line passing through the axis is called as axial line, and the line passing perpendicular to the midpoint of the dipole is called equatorial line. Now this corresponds to the axial line, and this line which is perpendicular to the dipole and passing through the midpoint of the dipole is called as equatorial line, and the midpoint of the dipole is also called as center of the dipole. Now look here, one is the positive charge, another one is the negative charge. What is the net charge of the system? It is plus q minus q, so net charge is 0. The charge of the electric dipole is 0. Then what is the characteristic of the dipole? Therefore, charge is not the characteristic of the dipole. The dipole is characterized by another quantity called dipole moment. Dipole moment, and it is denoted by the letter P. It is also a vector quantity. Dipole moment is the characteristic of the electric dipole, and its magnitude is given by the magnitude of the dipole moment is product of either of the charge, any one of the charge, and the distance of separation between the two charges. The magnitude of the dipole moment is the product of either of the charge and distance of separation between those two charges. Therefore, magnitude of dipole moment P is equal to, we can write it as 2a q. That is the dipole moment. Since we have stated that dipole moment is also a vector quantity, what is the direction of the dipole moment? For convenience, we have taken the direction of the dipole moment is from negative charge towards the positive charge. So therefore, this dipole possesses a dipole moment, and the direction of the dipole moment is always from negative charge towards the positive charge. That is the direction of the dipole moment. Then what is the SI unit of dipole moment? Now we have a charge, its unit is coulomb, and we have the distance of separation, its unit is meter. Therefore, SI unit of dipole moment is coulomb meter. You have to write capital C, small m. You are not supposed to write in this form, MC. That corresponds to millicoulomb. That leads to milli. That is 10 to the power of minus 3 coulomb. That represents. Therefore, we have to write it in terms of coulomb meter. Therefore, dipole moment is the characteristic of an electric dipole. Next, we are going to study what is the expression for electric field due to a dipole for the two cases. For a point along the axial line. Second case, for a point along the equatorial line. Now we will derive an expression for electric field due to an electric dipole along the axial point. Now what is a dipole? It is a pair of equal and opposite charges opposite point charges separated by a small distance. The distance of separation we have taken 2a. Now here consider 2 point charges, one is plus, another one is minus. They are separated by a distance of 2a. Now take the midpoint of that dipole O as the center of the dipole. Now what is the axial line? The line passing through the axis of the dipole is the axial line. Now along the axial line we are considering some point P. Now that point P is at a distance r from the center of the dipole. For convenience, we have chosen the point towards the positive charge. For convenience, we have taken this point towards that positive, that is very near to the positive charge, and it is very far away from the negative charge. With that consideration, we are going to obtain the expression for electric field due to that dipole. Now this dipole has a dipole moment denoted by vector P. Vector P represents the dipole moment. Now where is the direction of the dipole moment? It is from negative charge towards the positive charge. The direction of dipole moment is from negative charge towards the positive charge. Now this point P is at a distance r from the midpoint of the dipole. Now we have to obtain the expression for the electric field. Now we have to write the expression for electric field at the point P due to the individual charges, first with the positive charge and second with the negative charge. Now what is the distance of the positive charge from the point P? It is r minus a. What is the distance of the negative charge from the point P? It is r plus a. So therefore the electric field due to the positive charge, let me write it as E plus. E plus represents the electric field at the point P due to the positive charge. Now that is, we know the formula, 1 divided by 4 pi epsilon naught charge Q divided by distance square. Now distance here it is r minus a, because r is the distance from the midpoint, but the charge is at here, therefore we have to subtract a, r minus a whole square. Now this is the electric field E plus. What is the direction of the electric field at the point P? Now it is towards left, because this charge is a positive charge. The electric field is always radially outwards for a positive charge, therefore it is towards left. Now compare this direction of the electric field with respect to the dipole moment. Okay, now we are comparing the direction of this electric field due to the positive charge with respect to the dipole moment. They are parallel. The dipole moment is along the same direction and the electric field due to the positive charge is along the same direction. Therefore here we will write P cap. P cap is a unit vector in the direction of the dipole moment. So similarly, the electric field due to the negative charge, electric field due to negative charge, E minus in the vector form is equal to, the magnitude remains the same, 1 divided by 4 pi epsilon naught here, charge is the same. Should remember, while writing the expression for electric field or electrostatic force, even though we are having a negative charge, here we are going to take only the magnitude. You are not supposed to write minus q charge. What does the negative sign indicates? It indicates only the direction, whether the electric field is towards or away, or the force is towards or away. That only it indicates negative sign. Therefore, while calculating electric field and also electrostatic force, we are not supposed to use the negative sign for calculation purposes. Okay. So with that thing, 1 divided by 4 pi epsilon naught, once again the charge is same q, divided by distance r plus a whole square. It is r plus a This is the magnitude. Now we have to put the unit vector. Now look here, since it is a negative charge, therefore the electric field at this point due to the negative charge, it is towards the negative charge, E minus. It is E minus. Now this electric field is from positive charge towards the negative charge direction, but the dipole moment is from negative charge towards the positive charge direction. They are anti-parallel. Therefore, in order to represent the anti-parallel nature, we are placing a negative sign for the unit vector. That means this E minus field is in opposite direction to the dipole moment vector. Now this is the electric field due to the positive charge and field due to the negative charge. Then according to the principle of superposition, what is the total field at the point P? From superposition principle, the total field E is equal to, it is the vector sum, that is vector E plus, it is the vector sum. Therefore, you are not supposed to put minus sign. Okay, it is a plus sign, vector sum, because we have used the vector notation. Now substitute the values. Now first one is 1 divided by 4 pi epsilon naught q divided by r minus a whole square. For the second expression, we have a negative sign. I am writing that negative sign first. 1 divided by 4 pi epsilon naught q divided by r plus a whole square. Okay. Now this p cap, it is a unit vector. I will write it on common outside. Clear? Now let me simplify these things. Okay. The electric field E is equal to Q divided by 4 pi epsilon naught is common, taken it out. Q divided by 4 pi epsilon naught. Now here I am left with 1 divided by r minus a whole square minus 1 divided by r plus a whole square. Okay. Now further simplification, 1 divided by 4 pi epsilon naught. Look at the denominator, it is r minus a and r plus a. So taking the LCM of these two, it is r minus a whole square into r plus a whole square. That can be written as r minus a into r plus a is r square minus a square whole square. Now taking the LCM, I am getting r square minus a square whole square. Now this cross multiply these two, so and expand r square plus a square plus 2 ra. Now this one cross multiply, we are having a negative sign also, therefore it is minus r square minus a square minus of minus plus 2 r into a. That is the thing. Now further with p cap unit vector, we are having a p cap. Now further simplification leads to, so q divided by 4 pi epsilon naught. Look here, plus r square minus r square plus a square minus a square get cancels. 2ra plus 2ra, it is 4ra divided by denominator r square minus a square whole square with p cap. Now this is the expression for electric field due to a dipole along the axial point. Now if we rearrange the terms, I am going to get 1 divided by 4 pi epsilon naught. I will take q inside, that is 4 a q r divided by r square minus a square whole square with the unit vector p cap. Now what is the direction? Its resultant direction is also from leftwards. It is towards the left side. Resultant field is also towards the left side. So therefore, the resultant field and P are parallel to each other. But we have known that this electric dipole has a dipole moment P is equal to 2AQ. Now here 4 can be written as 2 into 2. Therefore 2AQ can be written as P. So therefore the electric field is given by 1 divided by 4 pi epsilon naught into 2P. 4 can be written as 2 into 2. 2AQ is replaced by the dipole moment P. Therefore 2P into R divided by R square minus A square whole square with P cap. That is the expression for electric field along the axial point. Now here we will make one assumption that if this point is very far away compared to the size, distance of separation, if the point P is at very far away compared to the distance of separation of the dipole, then the further simplification leads to 1 divided by 4 pi epsilon naught 2PR divided by, in the denominator I am taking here R square term outside. If I take R square along with the square, it becomes R to the power of 4. It is taken out. Therefore, it is 1 minus A square by R square whole square. Okay. Since R is very much greater than A, therefore A square by R square is approximately equal to 0. So this term becomes 0. Therefore 1 square is 1. Therefore we left with E cap is equal to, now 1 R get cancels here. Therefore 1 divided by 4 pi epsilon naught 2P divided by R cube into P cap here is there. Now that is the final expression for electric field due to an electric dipole for a point along the axial line. This is the final expression. Now this electric field and the dipole moment are parallel. They are parallel to each other. That means they are in the same direction. Now this point P is also called as end on position or end on point.